And that's where we gotta stop. I know, it's just getting good. All right, well, good morning, everybody. I'm sure we can make this class just as much fun. Okay, maybe not quite as fun as Johnny Be Good, but we'll make an attempt, okay? As close as we possibly can get. Today's quotation is a reminder to always keep moving, keep making progress, okay? Whatever it takes. And I think that's a good thing that all of us need every once in a while. With that, let's move forward into some Algebra 2. Not that, that's geometry, which is good too. And we have been working on graphing our polynomials now. So go ahead and open yours up and compare your graphs to mine. They should look pretty close to similar. Although mine did not come out as beautiful as I would have liked. In trying to be very precise and hit those exact points, it doesn't come out very smooth. I get a little jittery there, my curves. But you should definitely come in, like you have the y-intercept here, you have some known points there. You know that this has to flatten out, take a dip, and then come back up. Okay, so the general shape should match fairly close. And we don't have a value for that minimum there. We don't know how far that actually dips down unless you were to plot additional like fractional points in between. So don't fret that part. This should definitely go up, down, back up, and then turn around. So you need that little M shape there. All right, 4 is a cubic, so up, down, and then back up again. At the y-intercept and the 0 right there. 5 is can be a little tough to tell. I would have preferred to space this out myself. I counted this as like, this is 1, this is 2. All right, just so you can really see more of the curvature to it, because right now it was really hard for me to draw and not make it turn out to look like just a straight line. But you should have a little bit of double bendiness right around that y-intercept. And then number 6, I think, is pretty straightforward. Again, you're looking for this smooth curve here. I know it's hard to know how it's going to connect if it's just going to be like a straight line and curve up like this. Okay? But we will slowly, as the years go by, develop additional tools, particularly calculus has a specific tool for letting us calculate that curvature, whether it should be bending upwards or downwards, and you'll get into a little bit of that in pre-calc. All right, any questions there from yesterday's graphs? No? All right, then for today, you are going to work on mostly the same, except now on this page, the additional element we're going to add is estimating the maximum and minimum points. Now, the last one had the directions that they asked you to estimate where the zeros fall between here and there. I didn't emphasize that part or include it in my solutions because we've already talked about finding the zeros specifically, okay? There's no point in estimating those when we have the tools to get them exactly. But we don't have any tools for getting the maximum and minimums. We have no way to tell what this point is. It looks like probably at -4. I guess I could plug -4 into the function and probably get more precise than 8, 16, 24. So this is what, 28, maybe 29. Looks like about 29. 20, could be 29 and a half though, I don't know. Okay, but that's what we want to try to find is these points here that are not zeros. They are though very special extrema. That's the general term. If you need one word to mean maximum and minimum, you can call them extrema. Or singular extremum would be the unknown. Well, it's one of those turning around points. It's a max or a min. I don't know which it is yet. You can call it an extremum. All right, so we're trying to find these points that are just so extra. And for today's process, we're just going to stick with create your table, use the graphing calculator to do that. Okay, no sense plugging all these in by hand, wasting your time that way. Use the graphing calculator to create your table. Then use your table to plot some points, draw in your curve by hand. And then from that, we can tell, both from the graph visually and looking at our table of values, where, thereabouts, there is a relative maximum or minimum. Keep that in mind. We're talking about the relative maximum. This guy goes all the way off to positive infinity forever and ever, right? There's no true maximum of this function. It could just keep getting bigger and bigger. It could go out to infinity. So we say relative, or sometimes local. And we're talking about whereabouts on the function can we find something where it does this, where it comes up and then turns back around. Okay? That's why I also refer to these as a turning point, because the function turns around. And so you can kind of see that plotting 22 to 29, that's an increase. 29 to 24, well, that's a decrease. It went up and then it came back down. So that's a good sign that, hey, this should be a relative maximum. So you can check those both on the table and on the graph itself. All right? Okay, questions there? All right, then your work today will be those 6 functions. Very basic, right? The most complex of which is only x to the 5th power. Don't worry about that guy too much. So it's only got 3 terms anyway, so it's not even that bad. All right? So same process. Create the table, plot the points, find the local maximum and minimums. Okay? Not the ends where they shoot off towards infinity, where they turn around. But that is for later. Before we do that, I need to put you to the test. We are going to run a quiz. And let me grab the correct window here. There we go. So this is real short. I think it's 11 questions, right? Dealing with the graphs of your polynomial functions. So go ahead and go to joinmyquiz.com. Enter the code 799604. $799,604. There they come. And I think I'm going to want to turn this down. Yeah, the quiz is music. It's fairly loud. All right, I think that's everyone. So let us begin. Once again, you can have out your notes, you can have out your calculator, you can do whatever computation you need to do. I don't think any of them are that terrible, but please don't feel like you have to resort to graphing the whole thing every time. Look for those patterns. What do you expect to come out of that shape? How many times does it turn around? How many zeros does it have? Right? That kind of information. Good hints. 56, 55%. Tougher than you thought, huh? Keep going to the end. Take your time, work it through. When you are finished with the quizzes, please review the questions there and see what you got wrong and how you got it wrong. You can fix that mistake in the future. Right? Specifically, you can then retake. I will be posting the retake at the end of the class day, so 2:30. Otherwise, you can go ahead and get started on today's practice exercises. More about the quizzes, questions, once everyone is finished. Good job, Liliana. Taking the lead there. That was tough all around, wasn't it? All right, let's look at what gave you the most trouble. 2, 4, 10, 11. Matching the graph to the function. All right, look at this graph. It goes down, turns around once. We know that's what happens in a parabola, right? The one turn. You go from linear to parabola. From x to x squared, you get one turnaround. And if you go to x cubed, it turns around again. So we have 1, 2, 3 turns, right? For a total of 1, 2, 3, 4 kind of segments, either going up or down, which means we're looking for something that is to the 4th power here. So we can eliminate that third option there. And let's see, what's the difference? Ooh, this has got a negative and this is positive on each one. Okay, let's see if we can't figure that out. When in doubt, always ask, what happens if I plug in 1,000,000? This function, if I go all the way out to x equals 1,000,000, this line is going to be way up here, right? Way off the charts. Very, very positive. So we want either the second or the fourth. The first one with that negative would flip it upside down, and big positive x's would go into a negative function value. And so now we have to ask, what's the difference between these two guys? There's not much we can do about the little coefficients in the middle. We can't really tell that. But we can look at the very end. If I put in a 0 for x, everything goes away except the constant on the end, and I get my y-intercept. What's the y-intercept here? Is it +1 or -6? Clearly must be -6. This should be the fourth answer, x to the 4th plus x cubed plus 5x squared minus 6. All right? So here's what we're going to do. Next week, we're going to put everything together. And we're going to find out what are the shortcuts, what are the basic features that will let you be able to complete this quiz in like 10 seconds flat. Okay? Okay, maybe that's a little ambitious. Maybe 30 seconds. You got to move the mouse and click the buttons. How about that? 30 seconds. That's going to be my goal. You'll get to retake this for the rest of the week, sure. But my goal is next Monday, I'm going to give you the tools to be able to answer these types of questions without hesitation. You'll know, oh, boom, both pointing up, that's got to be even, it's got to be positive, it's got to be 1 to x to the 4th, it's got to have a negative y-intercept, done. You'll be able to find that solution super fast, okay? So we'll put all of that together, how to spot these major features using number of turning points, number of zeros, end behavior, where are the final arrows pointing, what direction, what does that tell us about it? Okay? And we can use that to both identify graphs quickly and easily, and going the other way, from a given function, you can whip up a quick sketch. It won't be specific enough to determine any values from, but it'll at least be able to create a picture in your mind faster than you could type it into the calculator and graph it that way. Okay, that's my goal for next week. So, challenge has been set. Stay tuned for that. Otherwise, we've still got 7 to 18 minutes in class. Go ahead and use that to complete those 6 graphs from today's exercises. And I will leave you to that.